Hello everyone, welcome back to my channel. In this video lecture, we will cover a new chapter of chemistry, that is hydrocarbons. Hydrocarbons are compounds of carbon and hydrogen. The important fuels like petrol, kerosene, etc. are all hydrocarbons or their mixtures. Then classification of hydrocarbons. Hydrocarbons are classified into acyclic or aliphatic, which is open chains, and then carboxylic or cyclic. Acyclic are classified into three: alkanes, alkenes, and alkynes. Then cyclics are classified into two: alicyclic and aromatic. Alicyclic is classified into three: cycloalkanes, cycloalkenes, and cycloalkynes. Alkanes are also called paraffins. Its general formula is CnH2n plus 2. They all are sp3 hybridized, and the bond length is carbon-carbon bond length is 1 to 1.54 angstrom, and then they are chemically unreactive. They show chain position and optical isomerism. Their nomenclature is according to this. Then preparation, they are prepared by first Wurtz reaction. They follow mainly free radical mechanism, useful in preparing an alkane containing even number of carbon atoms. Most important important topic of alkanes, that is Wurtz reaction, and its use, why it is useful. It is where it is useful. It is useful in preparing an alkane containing even number of carbon atoms. Then second way to form alkanes are from Grignard reagent. Then third, from unsaturated hydrocarbon, that is Sabatier and Sanderson reactions. Then fourth, from carboxylic acid, that is decarboxylation method. Its physical property: nature is non-polar due to covalent nature of carbon-carbon bond and CH bond. Then solubility, they dissolve like and unlike dissolve unlike. Polar compounds dissolve in polar solvent, and non-polar compound dissolve in non-polar solvent. Boiling point: low boiling point due to non-polar in nature. Then the boiling points of the branch chain alkanes are less than the straight chain isomers because of the fact that branching of the chains makes the molecules more compact and thereby decreases the surface area, and consequently the magnitudes of van der Waals forces also decreases. Then its chemical property: first, combustion. Alkanes on heating with air undergoes complete oxidation to give CO2 and H2O along with a large amount of heat. Second, substitution reactions. First, halogenation. Iodination is a reversible reaction, so it is carried out by heating alkane in the presence of some oxidizing agent like iodic acid or nitric acid or mercuric oxide, which oxide Hi formed during the reaction. Then fluorination of alkanes takes place explosively, resulting even in the rupture of CC bond in higher alkanes. The features of halogenation: the reactivity of halogens: fluorine, chlorine, bromine, and then iodine. Then the mechanism: halogenation reaction takes place by free radical mechanism. The reaction proceeds in following steps: first, initiation, chain initiation; second, chain propagation; third, chain termination. Then third, chemical property: nitration. The reaction takes place by free radical mechanism at high temperature, that is 450 degrees Celsius. At high temperature, CC bond is also broken so that the mixture of nitroalkanes is obtained. Then sulfonation: replacement of hydrogen atom of alkane by SO3H group. Then isomerism. Then aromatization. This method is also called as dehydrogenation or reforming. Similarly, heptane gives toluene, N-octane gives O-xylene, and 2-methylheptane gives M-xylene. Then thermal decomposition or pyrolysis or cracking or fragmentation. When higher alkanes are heated at high temperature in the presence of alumina or silica catalyst, the alkanes break down to lower alkanes and alkenes. Then this topic is not much important, so we will not study. Then next came the alkenes. They are unsaturated hydrocarbons having double bond. General formula is CnH2n. They are the bond length is 1.34 angstrom, and they are sp2 hybridized. When we treat alkene with chlorine, oily products are obtained. So alkenes are also called olefins. They show chain position and geometrical isomerism. Then they are prepared from alkynes. Alkynes on partial reduction with partially deactivated palletized charcoal known as Lindlar's catalyst gives alkynes. Then from haloalkanes also, the process is known as dehydrohalogenation. Then from dihaloalkanes, dehalogenation. From alcohols, dehydration. And then the chemical properties: addition reaction, first the addition of hydrogen, addition of halogens, and addition of hydrogen halides. Then the most important topic, peroxide effect or kharash, that is known as anti-Markovnikov's addition. In 1933, Kharash and Mayo observed when HBr is added to an unsymmetrical double bond in the presence of organic peroxide, the reaction takes place opposite to the Markovnikov's rule. Peroxide effect is applicable only to HBr and not to HF, HCl and HI. Addition of HF, HCl and HI takes place according to Markovnikov's rule even in the presence of peroxide. Then addition of water, hydration, oxidation, combustion, hydrogen oxidation. This reaction is called hydroxylation. Cis product, that is cis diol, is obtained. And then the next topic, alkynes. Then unsaturated hydrocarbon having triple bond, general formula is CnH2n-2. They are sp hybridized and show chain position and functional isomerism. They are prepared from vicinal dihalide, or they are also prepared by action of water and calcium carbide. Then its chemical properties are hydrogenation, then polymerization, linear polymerization, acidity, and then we have the most important and easiest topic of hydrocarbons, that is aromatic hydrocarbons. Aromatic compounds containing benzene rings are known as benzenoids, and those containing a benzene rings are known, those not containing a benzene ring are known as non-benzenoids. Then resonance, just see the structures, and this whole chapter is based on the equations, the main equations like Kharash effect, anti-Markovnikov's rule, Sanders and Sabatier reaction. All the reaction which I have mentioned in this PDF, just go through this PDF and you will get nice marks in this. Hydrocarbon will be done if you read this PDF. Now just we continue the chapter. Then aromaticity, the compounds that follow the following features are to be considered aromatic. First, planarity. Second, complete delocalization of the pi electrons. Third, presence of 4n plus 2 pi electrons in the ring where n is an integer. This is often referred to as Huckel's rule. Then if someone asks you what is Huckel's rule, just say that 4n plus 2 pi electrons is the Huckel's rule. And n is a number, n is an integer which can be 0, 2 or 1. Then preparation of benzene, it is prepared by cyclic polymerization of ethine, then decarboxylation of aromatic acids, and by reduction of phenol. And physical properties are aromatic hydrocarbons are non-polar molecules and are usually colorless, liquid or solid with a characteristic aroma. Aromatic hydrocarbons are immiscible with water but are readily immiscible with organic solvents. They burn with sooty flame. Its chemical properties are arenes are characterized by electrophilic substitution reaction that proceed through a following three steps: generation of electrophiles, second, formation of carbocation intermediate, third, removal of protein from a carbocation intermediate. Three types of few reactions are there: halogenation, nitration, sulfonation, Friedel-Crafts alkylation, and Friedel-Crafts acylation. In nitration, you just learn the equation. In this, we use concentrated HNO3 plus concentrated H2SO4 to get nitrobenzene. For halogenation, we add any halogen and we use it as an anhydrous AlCl3. In sulfonation, fuming sulfuric acid is added, H2SO4SO3, and in Friedel-Crafts acylation, we add CH3COCl and plus anhydrous AlCl3. In Friedel-Crafts alkylation, C2H5Cl or anhydrous AlCl3. Then directive influence of a functional group in monosubstituted benzene. First, ortho and para directing group and activating, meta directing and para directing. Then carcinogenity and toxicity. Benzene and polynuclear hydrocarbon containing more than two benzene rings fused together are toxic and are said to possess cancer producing carcinogenic property. So this was for the video. Your hydrocarbon is completed, and once you go through this video, go through this whole PDF, you will get the chapter. It is very important chapter, very scoring also. So hope you liked it and understood it. Just go through the PDF, take the screenshot of it. Thank you for watching my video. Hope you liked it, and don't forget to subscribe my channel. Please don't forget to like, share and comment also. Thank you.